Hello, how you doing? It's MrDoTheMath, and today we're going to talk about proportionality theorems, right? The proportionality theorem. All right. And so basically what we've been talking about is similar triangles, right? And so now we're going to look at another way to decide that triangles are similar. All right. The first theorem is this one. If I have two parallel lines, right? Bam, bam, bam. Let's draw a triangle. Q, T, R, U, S. Right? If I have two parallel lines, remember this mark means parallel, right? If I have two parallel lines that intersect another side, or two sides, they intersect this side here, QR, and they intersect this side, SR. They're parallel, then those sides are proportionate to each other. All right. So if let's see, if parallel, then the sides are proportionate. All right, proportionate. A-E. All right. What I'm saying is, these two lines are parallel. These are parallel, and they intersect this side QR. Then QR, when you can break QR up, and they're going to be proportionate to each other. So that means QT, which is this part, is going to be proportionate to TR.
TR.
Yeah, TR. It's on the same side, right? And SU is going to be proportionate to UR. Okay? So, proportionate does not mean equal. So even though this is intersected, it's not saying that these are equal to each other. It's just saying that this ratio, these two ratios are going to be equal to this ratio. So the ratio of this side is equal to the ratio of that side. That's it. Okay? So we write that down. Ratio of one side is equal to the ratio of the other. We good with that? All right, cool. So the converse is going to be what? What does converse mean again? What does converse mean? Remember? Converse, yeah, beginning of the year. Beginning of the school year. Converse. The reverse. So what would the reverse say? Yes.
The sides are proportional to the lines of parallel.
Right. So they're saying if they're proportionate, bam, bam, then these two lines are parallel. That's it. So the converse would say, let me see, give me some labels.
R.
R.
A.
V. Oh my gosh.
E.
I know where this is going.
E.
Oh, yeah, let it get away with that. Alright. So if RA is a ratio of AV and NE is ratio of EV, then RN, segment RN is parallel to AE, right? Okay? This is the converse. And so because of this, then let's go back to here. We got QS is parallel to TU. Everybody good so far? Okay. So let's try one. Okay. So in this example here, we got this triangle, new triangle, right? We're gonna label it R, Q, S, U, T. All right. If this is 4, this is 6, this is 9, and we said these are parallel. All right. Let's find the measure of QR. What is QR? Okay. So help me write out the ratio. What would the ratio be? Can you see that, Oscar?
Yeah.
Yeah? What would the ratio be? Yeah, Chris. Give me some. What was you gonna say? Yes.
RS over ST.
So RS over ST equals what? Over who? QU. Alright, so we got number values. So what's those numbers gonna be? 4 over 6 equals x over 9. Okay? Then from here we cross multiply to solve for x. So we get 36 equals 6x. X then equals what? 6. So RQ is 6. RQ is 6. Okay? So we're using the idea of triangle similarity, parallel lines, and to find parallel lines to find missing sides. Right? To find missing sides. Okay? So in essence, what two triangles are similar? What two triangles are similar? Dylan, what's the two triangles? RQS is similar to what? RUT. Is that what you said? RUT, right? And so to further prove that point, remember when we talk about parallel lines, we have corresponding angles, right? We got corresponding angles, and then we got the reflexive angle here, right? Everybody has R, right? These are equal to each other. These are equal to each other. And remember a couple of days ago we said if two triangles have the same, if they have equal angles, then those triangles are similar, right? So we have all we need, right? So there we go. So those are the first two. So we got the if parallel, then the sides are proportionate. If proportionate, then parallel, right? So this is the regular. This is the conditional statement. This is the converse. Okay. Let's move on. Let's go and look. Let's look at another example. All right, and then we'll just talk about it. This is B. This is D. This is C. A. E. This is example 2 of this problem here. If BA is 33, DE is 25, and this is 44, okay? Are these going to be, so we're going to find out if they're going to be proportionate again, all right? So let's set up the proportion. Let's set up the proportions. Come on. Yeah, give it to me. What you got?
CB over BA.
All right, CD over.
No, I said CB.
CB. CB over
BA.
BA equals
CD over DE.
CD over DE. All right, what's my numbers? Yeah, Raven.
X
X
over
33 equals
44 over 25.
44 over 25. All right. All right. I need calculators out. Let's cross multiply. So we got 25x equals 33 times 44, which is, go that way. What is it? 1,400 and what? 53?
52.
52. All right. Let's divide that by 25.
58.08.
58.08. All right. So, are they proportionate? 58.08. 58.08 over 33. Does that 58.08 over 33 equal 44 over 25? Huh?
No.
No? They're not equal. Since they're not equal,
It equals it.
this equals that?
Yeah.
I think she was too dumb.
Did you put it in the calculator? So,
It equals.
it equals?
Yeah.
It does?
Yeah.
Miss Nelson.
Comes out to
going
1.76.
Say it again.
1.76.
3.76?
1 point.
So you did 44 over 25 equals 58 over 33?
Wait, Miss Nelson, wait. Wait, what? Oh.
If you divide them.
No. Yeah, 55 doesn't.
Yeah.
It is the same thing, Miss Nelson.
44 over 25 and
Mess something else.
oh, so something's not right.
It's fishy. They're the same.
All right, did we multiply this right?
That's you.
Let me see.
What'd you say? Come on.
So because it should have been 27 over 33.
You said something.
Should have been 27 over 33.
27.
Yeah.
What is we doing? Miss, that's right.
We divided this by 25?
Yeah.
33 times 44?
Let me, my calculator's
Not what it's supposed to be in the book.
It's
No,
the
it
same
says,
thing.
this in the book it says,
1452 divided by 25.
AB is 33, AB is 33, AB is 33, right? And we got BC is 27.
Miss,
We don't got that.
We don't have BC.
You didn't give us BC.
Oh, 44 and 25. Oh, alright, so there we go. BC was 27. Okay.
Oh,
So yeah, we solved it right, right? So, it's all good, it's all good. Alright, so then, they are equal. This is equal, right?
Yes.
But if we got these sides, we got 27
Nope.
over 33 equals 44 over 25, right?
675.
So this would be, you can just reduce this and reduce this.
Oh yeah.
27 is what? These are both multiples of,
9 over 11.
these are multiples of 3, so that's 9 over 11. And then you got 44 over 25. Can those be reduced?
No. Nope.
Not really, 44 over 25. So these are not proportionate. So yeah, we figured out the actual answer. The actual answer was going to be, like you said, 5808. Alright, very good. Alright, so these are not proportionate. So basically I had to go back to this to show you guys that there are going to be cases where they're not going to be proportionate. If they're not proportionate, then these are not parallel. So since they're not proportionate, they are not parallel. Okay? So there are going to be cases where they're not proportionate and not parallel. Okay? Alright, let's go look at some transversals. Here we go.
Transversal.
Yeah, some more transversals. Alright, so let's look here. Here we go. If we got 2 transversals and 3 parallel lines, right? They're parallel. This is line R, this is S, this is T. This is U, W, Y, Z, X, V, right? So, if parallel lines intersect 2 transversals, then these segments are going to be proportional, right? So, let's write that down.
Oh, I didn't better.
If this case we got 3 parallel lines intersect 2 transversals, then sides are proportional. Alright? Basically what that's saying again is if these intersect these 2 transversals, right? Then UW is proportionate to WY, right? And also VX is proportionate to XZ. Proportionate means this ratio is going to equal that ratio. Okay? Those 2 ratios are going to equal each other. Okay? Last theorem. All right. We have another triangle. If a ray bisects.
He's not here.
Yeah.
He's not.
Why?
Where are you?
What's the matter?
What's wrong with you?
The second level. Come on. It's good.
Get it, just go.
If a ray bisects, alright? If a ray bisects the angle, its opposite sides are proportional to each other. Alright, so this ray bisects. Bam, bam. Bisects. What's bisect mean again?
Cuts in 2 equal sections.
Right. If a ray bisects, angle, then the opposite sides are proportionate. Proportionate to the sides of the triangle, right? So they're basically saying these sides are going to be proportionate to these sides. Okay? These sides are going to be proportionate to these sides. All right. So this right bisects, right? Let's call this A. This is CB, right? ACB, and this is D. Okay. Now, it bisects that. That's it. That's all it does. It doesn't mean that it cuts this in half, right? So note, all right, because it's bisecting, it's not saying that AD is not equal to DB, right? It's just an angle bisector. It's not a segment bisector. Okay? Remember that. It's just an angle bisector, not segment bisector.
Right.
All right. Okay. So what we're saying though is that AD over DB equals CA over CB. Right? AD over AB, A over DB, CA over CB. That's what's going on right here. Okay? Let's do an example of this one. Alright. Yeah, no, you need this example. You want this example.
Oh yeah, I don't know.
You really do. Alright, so here we go. We got a triangle, right? We got a triangle, right? It is bisect, right? PQS, we'll call this R, right? This is 7, this is 13. This side is X. The whole thing is 15. The whole thing is 15. This is why I need to see this. Right. The whole thing is 15.
Addition?
Huh?
No, hold up. Is that an R?
Yeah, that's an R. Alright, it's 15. Alright, what's our proportion? Like, what's our proportion based on the segments? Yes, ma'am.
Oh, I'm gonna try.
Try it.
QP.
QP over,
PH.
very good, equals
QR
QR
over RX.
over RS. Right. Alright, let's put some numbers there. Alright, QP is what? 7 over who what? 13 equals what?
15
Very good. 15 minus X. Right, look, because the whole thing is 15 and that side's X. So we're going to subtract X from this 15 to figure out what that is. Okay?
Over
15 minus X over what?
X.
Alright, so the whole thing is 15. This part is X. So that means that QR is going to be the whole thing minus the side we know, which was this X side.
Okay.
Okay? Then we solve.
195 minus 13.
Wait, hold on.
Alright, so we got 7 times X, which is 7X. And then, what'd you say?
195.
195 minus what?
13X.
13X. Okay? What's the next move, Lovato?
Why would you ask me that?
Because you was looking and thinking.
I'm trying to figure it out.
You trying to figure it out? Just tell me what we're doing. We'll do it.
No.
What are you going to do to 13?
Add.
Yeah, add 13 to 7. So we're going to get 20X equals
How long?
195.
9.75.
Alright, X equals 9.75.
Something wrong.
No, ain't nothing wrong. It's a decimal.
No, I did something wrong.
So X equals 9.75. Good. And then, so in order to find out what this side is, you will subtract 9.75 from 15.
That's what I did.
Right? And you should get what?
5.25.
525, right. 5.25. Right? Good job. Fantastic. Fantastic. We making good time. I got one more thing to show you. Let's look at one of these examples.
Yeah.
Let's look at one of these examples. Okay? Here we go. We're going back to our transversal and our 3 parallel lines, Jaden. You ready, dog? Alright, so bam, 2 transversals. Then we got it's broken again. 3 parallel lines. F, E, G, D, H, C. Alright, here we go. Alright, so this is 120. This right here. It's 120. ED is going to be 150, and DC is going to be 300.
Oh, you want
Okay?
us to do that?
Yes, we're about to do
Why
that.
that's so big?
Because it's just numbers. So there's two ways to do this, right? So they want to know what the measure of HF is. We want to know what HF is, right? We want to know what HF is, okay? So again, these are three parallel lines that intersect this transversal here. We're going to erase the old transversal example. Alright, so somebody tell me what our proportions would be.
FG
FG,
to GH.
FG over GH
And
equals what?
ED to BC.
ED and DC.
Mm-hmm.
Alright, so that's going to give us,
Is that a C?
well, yeah, that's a C. That's going to give us what HG is. We need to find HF though. So let's work this out though. Alright, let's make up. So what's our numbers?
120 over X.
120 over X,
150 over 300.
150 over 300. What's up, Raven?
What's that by the D?
By the D, this?
150.
150?
Oh.
Yeah. Alright, so cross multiply 120 times 300 is what?
36,000.
36
Oh my
what?
goodness, 1,000.
There we go. 36,000 equals 150x. We all good so far? Give me a head now, let me know we're good. Right? Then we divide by 150, right? Yeah. X equals 240. So what we're saying is this is 240. Alright, since we know that's 240, then HF is going to equal 120 plus 240, which is
360.
360. Alright?
360.
There is another ratio to solve this like right away. It's another way to look at it as well. Right? We can do the ratio of the whole thing over what we know and the ratio of this whole thing over what we know. Alright? Let's look at it. So basically what I said is you can do H, where's my, you do HG plus FG over FG equals CD plus ED over ED. Right? We don't know what HF is, right? So we can just, number-wise, we can just put HF there or X. It'll be X over FG 120 equals CD, which is 300 plus 150 over 150. Does everybody see what I did so far?
Nope.
No?
I need my
I
glasses.
just added these two together. That's what's at the top. Alright? That's one of the ratios that we talked about in like the first section of this chapter. Alright? So we added these together and we put it over what we knew, which was 150. We added these two together, which we don't know, and then we put it over 120. Assuming that we don't know that.
Wait, so you added the right side together?
Yeah, the right side. That's the top right here.
Wait, why'd you put over 150? Why not 300?
Over 150 because the corresponding side we know.
Oh, so we're, okay.
Right? We know the corresponding side. Okay? What's up, Justin?
Wouldn't it have been 120 plus X or minus X?
And 120 plus X. We could 120 plus X. But we can leave it all X though.
What you said?
Alright. So here we go. So we got 150 X equals 300 plus 150, which is what? 450. So 450 times 12. 120. 450 times. What is it? 54,000. Alright? Now if we divide 54,000 by 150.
360.
Yeah. X equals 360. X is HF, right? So we got it right away. HF is 360. Alright? So again, there's two ways to do that, right? You can use your regular proportion, this over this, that over that, solve and then add to get 360. Or you can add these together at the beginning, like this, CD plus ED over ED equals this plus that over this, and then you go straight to 360, right? So it's two ways to work that one out, okay? Yes, ma'am.
Why was it 240 the first time?
Why did we get two? We only got 240 the first time because we were only solving for HG at first.
Okay.
This right here was HG, right? For this one, it was HF, okay? So again, to recount, like proportionality theorem, so we have if they're parallel, those sides are proportionate to each other, right? If they're proportionate to each other, they're parallel. Then we have if three parallel lines cut two transversals up, then these are proportionate to each other, right? And then we have if an angle bisector runs into a side, these sides are proportionate to the other sides of the triangle. Okay? Good. Any questions? Yes, ma'am.
Why are you dividing it by FG and ED?
Because we knew these corresponding sides in the beginning of the problem. We only knew FG and ED, right? For both sides. We didn't know HG, so we couldn't put these equal to each other, right? Good question. Any other questions? Okay. Well, it's been great. Don't forget to like and subscribe. If you have any questions, comment below. MrDoTheMath out.
That was a 2 hour.